Hi everyone. So today we're going to work on dividing. So the other day, remember, we did multiplying and we simplified and then we multiplied together and then we simplified. So today we're going to work on dividing. So we're going to divide and simplify radical expressions, and then we're going to need to take care of a problem. The thing about division is that you're kind of like the rules, math etiquette, if you want to think of it that way, is that we're not allowed to have a radical in the denominator of a fraction because it's kind of in bad form. So what is called rationalizing the denominator. So we're going to look at those methods as well today, and hopefully by the end of today we'll have a pretty good idea of how to do that. So when we're dividing, let's take a look at something here. There we go, I lost my train of thought. Let's say we have the cube root of 27 over 8. Well, we can make this cube root of 27 is 3. Cube root of 8 is 2. We can also make this, the cube root of 27 over 8, as the cube root of 27 over the cube root of 8, which is 3 over 2. So we can do it as an entire thing, or you can separate it and do each one individually. And that's what our quotient rule is that you're allowed to either do it individually or you are allowed to do it as an entire fraction. My thing when I do division is I always want to look up and down, since if it's, say it's a square root over a square root or a cube root over a cube root, is there any way to reduce the fraction, even if it's separated, to reduce it to make our lives easier? Because let's be honest, we don't want, if the numbers are large, let's try and make them small. Okay, so for example, here we have the cube root of 27 and 27 over 125. Now, 27 and 125 really don't have anything in common. So we can separate this as the cube root of 27 over the cube root of 125. And we're going to get 3 over 5. That's it. Let's try this one. Okay, so here we have the square root. So we're going to separate the square root of 16, x cubed, square root of y to the 8th. Now, not only are we going to be able to have to simplify this, but we're also going to have to use our rules that we talked about with variables and exponents and things like that. All right, so we can take the square root of 16 and then square root of x cubed. So I'm really separating this out. Okay, so the square root of 16 is 4. The square root of x cubed, well, that's the square root of x squared and square root of x. So this is going to be x square root of x over the square root of y to the 8th is y to the 4th. Okay, so we're going to have to use those rules of simplifying that we talked about earlier. All right, let's try another one. Now see here, they're both square roots. They're already separated, but I can take 80 and divide it by 5. So 80 divided by 5 is the square root of 16, which is 4. That's a lot easier to deal with than separating it and dealing with the square root of 5 in the bottom. Let's try one more. So square root of, now we can't do the 2 on the outside with 72. But we can do the square root of 2 with the square root of 72 because they're both underneath square root signs. So 2 goes into 72, 36. See, no lower square root in the bottom. Square root of 36 is 6. Can't do anything with that xy. And then let's do one more thing. Let's simplify 6 over 2. There we go. All right, so I think that was it. All right, so there's 2, 4, 6, and 8. Why don't you guys try those? Pause the video and try those. Okay, so here is 2, square root of 25, square root of y squared. It's pretty easy. All right, cube root. So we did cube root of 27. Cube root of 14. So I did 3 into 14 and got 4 with 2 left over. Cube root of 8 is 2. Cube root of x cubed is x. Okay, so 32 divided by 2 is 16. Cube root of 16, well, I had to simplify it. I had to do 8 and 2. Cube root of 8 is 3. 5 times 3 is 15. Okay, 18 divided by 3 is 6. Can't do anything with the b. Oh, here, b to the 5th. B, that becomes b to the 4th. And notice no more denominators when we do that. That's kind of nice. Can't do anything with the square root, the 4th root of 6. We can make the 4th root of a to the 9th as a squared with a. And b to the 4th is b. So our final answer is a squared b, 4th root of 6a. Okay, so we're combining a lot of things here in our division. Okay, so we're doing our simplifying, we're dividing, we're simplifying our radicals. All of that's coming into play here. All right, so one of the things we're not allowed to have in the bottom of our fraction, kind of bad math, we're going to get rid of the denominator. So basically, we're going to rationalize the denominator by multiplying the numerator and denominator by, shall we say, what makes the denominator, because nobody really cares about the denominator. I lost my train of thought. Okay. Meter. A perfect. Now, if we were rationalizing the numerator, we would say we're going to multiply top and bottom by what's going to make it the numerator a perfect. Okay. Okay, so here's what I mean. Here we have the square root of 7 over 3. Okay, so we're going to split. So we get square root of 7 over the square root of 3. There is nothing we can do with 7 and 3. Okay, so 3 can't have the square root of 3 on the bottom. So I need to multiply 3 by what's going to make it a perfect, in this case, square, because we're doing square roots. If it was a cube root, I would want to make it multiply by what's going to make it a perfect cube. Okay, so here's what I usually do. Okay, I look at my denominator and I go, okay, what is it and how can I get it to be a perfect? Well, I have 1 3 there. How many more 3's would I need to make it a perfect square? 1 more, because 3 squared is 9. So I'm going to multiply top and bottom by the square root of 3. Now, if it was a cube root, I'd need 2 more 3's, right? Because 3 3's is a perfect cube. So we're going to multiply straight across, and I get the square root of 21 over the square root of 9. And we know the square root of 9, that's 3. And you're done. Do not divide the 21 by 3. 3 is an integer. 21 is an irrational. You can't divide those. It's like they don't play well in the sandbox kind of thing. You can't divide them. 2 different types of numbers. All right, let's try another one. Okay, so I have the square root of 4. Again, we might want to simplify first before we do anything, because we can take the square root of 4. All right, that looks a little better. We have less square roots. Okay, so because I'm dealing with a square root, what's going to make x a perfect square? Well, another x. So multiply straight across. Okay, what's the square root of x squared? X. And again, I can't divide the square root of x by x. One's irrational, one is rational. Okay, so let's try the other 2. Okay. So this is a cube root. So I split my root. 16 is 2 4's. I need 1 more 4 to make it a perfect cube, right? 3 of them are the same as a cube. So I'm going to multiply top and bottom by a perfect cube by 4 to make the denominator a perfect cube. So I multiply straight across. I get the cube root of 20, cube root of 64. The cube root of 64 is 4. Let's try that. This is the one that's a little complicated. Okay, so the first thing I did is look in see if I can reduce anything, and I can't. All right, cube root of 25, BC5. 25 is 2 5's, so I need another 5. I have 1 B, I need 2 more B's. I have 5 c's. I'm going to need one more because it would be c squared, c squared, c squared to get to c to the 6th. And that's what I'm going to multiply by. So multiply straight across. And I can multiply this cube root of a times it. That's why it becomes 5ab squared c. So 125. I have 1b and 2 more gives me b cubed. 5 c's and 1 more c gives me c to the 6th. Okay. All right. Cube root of 125 is 5. Cube root of b cubed is b. Cube root of c to the 6th is c squared. Now there is one more thing you can do. See these b's? They can divide out. So you're left with 3 times the cube root of 5ab squared c all over 5c squared. All right. Okay, so remember, you're trying to multiply numerator and denominator by what's going to make the denominator a perfect. Cube, square, fourth, whatever. Now that's going to hold true when we rationalize numerators. Now very rarely do we rationalize numerators, but it might be something that we're going to need in the future as far as like a technique. So again, we're going to multiply numerator and denominator by what's going to make it a perfect cube, square, whatever. So we're going to multiply numerator and denominator by what makes the numerator perfect. Okay. All right, so let's look at this one. We're going to do both these together. All right, so we have the square root of 7 over 20. So the first thing we're going to do is split our square root. So 7 over 20, square root of 20. Because again, we can't do anything with 20 and 7. They don't have any common factors to reduce that. Now again, it's all about the numerator now instead of the denominator. So since we're talking about square root, what do I need to multiply the square root of 7 by to make him a perfect? Would be another square root of 7, because that would give me 49. Okay, so multiply straight across. We get the square root of 49 over the square root of 140. Okay, square root of 49 is 7. Square root of 140. We could make that 4 times 35. So we could make this 7 and then 2 square roots of 35 if we wanted to. I'm good with 7 over square root of 140. All right, let's try one a little bit more complicated. So we have the cube root of 4a squared over the cube root of 5b. Again, about the numerator. So we have 2 2's here and 4. So let's write that out. Cube root of 2 is 2. And then I have 2a's here. Okay. So I need the numerator to have one more 2 and one more a. Oops. Okay, so let's multiply straight across. So we're going to get the cube root of 8a cubed all over the cube root of 10ab. Okay, cube root of 8a is 2a. Denominators, cube root of 10ab. All right. Let me know if you have any questions, guys. Again, let's go through this again. Okay, so we're going to want to separate our roots or keep them depending on what we're doing. Okay, we're going to try and take the cube root or square root of both the numerator and denominator if we can. Simplify is key. Okay, if we can divide top and bottom by the same number or simplify it up and down first before we do anything, that's going to make life easier. We're going to rationalize the denominator, which means we're going to multiply top and bottom by what's going to make it a perfect, okay, so that we don't have the radical in the bottom. And if we rationalize the numerator, we're going to multiply top and bottom by what's going to make the numerator a perfect. All right, let me know if we have any questions, guys. I'll talk to you again real soon, and hopefully you will stay safe out there.